Hello, grade 2. Welcome back to our online class. In our previous videos, we talked about addition and subtraction within 1000. I hope that you have mastered your skills in addition and subtraction within 1000 because in this video, we're going to apply those skills in solving word problems. But don't worry, I'm going to present to you, I'm going to help you on how to solve word problems easily. Here we go. One way to solve a word problem is using bar model or just model. What do you mean by bar model? Bar model is a pictorial representation of a word problem. There is a word problem, it's full of words, and with the help of bar model, you can visualize, you can picture out what the problem is all about. A bar model is an approach to solve a word problem. It's just an approach, a strategy, or just a method in solving word problems. And what are some types of bar models? Since you are still grade 2, I'm just going to present to you two types of bar model. So whenever you solve a problem, just think of these two types. Number one, part, whole, model. From the name itself, there's a part and there's a whole. How does it look like? It looks like this. We have one part, another part. You put the parts together in order to get the whole. Another type of bar model is comparison model. Comparison comes from the word compare. And this is how it looks like. We have the larger quantity and the smaller quantity. Here's what you should be mindful when making comparison model. You have to make sure that the models start at the same start line. We call this one as the same start line so that it would be easy for you to compare these two models, two bar models. Another thing is total. The total is you get or you add the number for the larger quantity and the number for the smaller quantity. That's how you get the total. And there's what we call here the difference. So the excess here, the extra here is what we call the difference. So those are the types of bar models. And how do we solve a word problem? In math, it is important to solve a problem or a word problem systematically. It means there should be a procedure, a process to be followed. The process that we're going to follow is what we call the U-Pack process. I've already introduced to you this process when you were in grade 1. U stands for understand. You understand the problem, you have to ask questions. Ask questions about the problem. If you can answer those questions, it means you have understood the problem. After understanding the problem, you are going to plan what to do. What you're going to do. Are you going to draw a model? If yes, what kind of model? Is it part whole? Is it comparison model? So it depends on the problem, right? After the planning, you answer, you work out your answer. Are you going to add? Are you going to subtract in order to get the correct answer? And C, check. You check if you have answered the question of the problem. Let's have problem number 1. Danielle has 14 blue paper clips. He finds 5 more red ones. How many paper clips does he have all together. After reading the problem, we have to ask questions. Who is the character in the problem? Or who are the characters in the problem? There's only one person mentioned in the problem, right? It's Danielle. Danielle has paper clips, and the colors of these paper clips are blue and red. How many blue paper clips are there? It says here 14. Do we know the number of red paper clips? Yes, it says here 5 more red. So we know the number of blue paper clips. We also know the number of red paper clips. And what is being asked in the problem? The number of paper clips all together. So that's how you're going to understand the problem. Next, let's plan what to do. We can draw a model, right? We can draw a model. And between part whole model and comparison model, I think the appropriate model for this problem is the part whole model. I'm sure of that because we are not comparing here. Okay, so first, let's have 14 blue paper clips and 5 red paper clips. Sometimes we're just going to use blocks, boxes, or just bars. In this case, I changed the paper clips to bars. So I have here 14 bars to represent 14 blue paper clips and 5 red bars to represent 5 red paper clips. What about if there are hundreds of paper clips? Are you willing to draw hundreds of bars here? I think it's no longer practical. In this case, it's advisable for you to just draw your model in this manner. So we have here 14, that's one part, 5, another part, and it's also important to put the question mark in the bar model because that will tell you or that will remind you what the problem is asking about. So in this case, the parts are given. You're looking for the whole. What do you do? Are you going to add or subtract? The answer is add. We have to put the parts together in order to get the whole. So we add 14 and 5 to get the whole. 4 plus 5 is 9. Then we have here 1. 14 and 5 make 19. Therefore, Danielle has 19 paper clips all together. Actually, there's already a keyword in the problem, all together. All together means you add the parts together. Let's check if our answer is correct. Let's check if we have answered the question of the problem. So how do you do that? You can double check your computation here, or you can answer the problem again. Let's have problem number 2. Mary has 25 erasers and 6 pencils. 4 of the erasers are star-shaped and the rest are round. How many round erasers does Mary have? There's only one person in the problem. This person is Mary. And Mary has some erasers and pencils. So here's my first question. How many erasers does Mary have? The answer is 25. How many pencils does Mary have? The answer is 6. Mary has 25 erasers. And the problem mentioned about the shapes of these erasers. What are the shapes? We have star-shaped and round. Star-shaped, star, round, circular, or circle. And how many of these erasers are star-shaped? It says here, 4. How many of these erasers are round shaped? It says here the rest are round, so we still have to find the number of round erasers. And in fact, that is what we are going to look for in the problem, because the question says, how many round erasers does Mary have? Okay, so let's have our model. In this case, it's still appropriate to use part-whole model. Just part-whole model. So I have here 1, 2, 3, 4 star-shaped, and the rest are round-shaped erasers. And take note also that we have here a total of 25 erasers. So the 25 here will be considered as the whole. The 4 star-shaped erasers will be considered as a part, and the round erasers will be considered as a part. Okay, or we can draw our model in this manner. So we have 4, question mark, and 25. It's also important to recognize what part of the model you are looking for. Is it a whole or a part? In this case, it's a part. Remember, in number bonds, when part is missing, you subtract. When whole is missing, you add the parts. So it's really important to translate your problem into a model. It's really important to draw a model based on the problem, because the bar model will tell you what operation you are going to use. In this case, we subtract 25 and 4 in order to find this missing number. So we have here 25 minus 4. 5 minus 4 is 1, and we have here 2. Therefore, Mary has 21 round erasers. And how do you check your answer? Again, you can solve the problem again, or you can just double check the computation here. Or let's see if 21 and 4 will make 25. So you have to answer those questions on your own. So that's how you check your answer. Problem number 3. There are 6 blue plates on a shelf. There are 18 more red plates than blue plates. How many red plates are there? Okay, so let's understand the problem. The problem talks about a shelf. In a shelf, there are some plates. Some of them are blue, some of them are red. Do we know the number of blue plates? If yes, what's the number? It's 6. Do we know the number of red plates? The answer is no. But we know that there are 18 more red plates than blue plates. We don't know the number of red plates yet. but the problem is providing us information like 18 more red plates. Okay, so based on this, I can say that the problem is comparing the number of blue plates and the number of red plates. What is my keyword? My keyword here is more than. If you see these words more than, it means we are comparing. It means you are comparing two quantities. If we are comparing two quantities, then we have to use the comparison model. Again, in comparison model, there are two bar models there. One is longer and the other one is shorter. Okay, but before that comparison model, let's have these objects first. Blue plates, there are 6 of them. And red plates, it says here 18 more. How do we do that? So up to here, the number of blue and the number of red plates are the same. To have 18 more red plates, you're just going to draw 18 more red plates here. There are 18 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 and 18 more. It's just like that. Or you can turn your model into something like this or just like this. So there are 6 blue plates and we don't know the number of red plates yet because that's what we're going to look for in the problem. And the difference here is 18. This is what we call the difference. The extra here, extra space here is what we call the difference. This is where you put the fewer or more than. So it says here 18 more than, so we have to put 18 here. Now, what operation are we going to use? Is it addition or subtraction? To help you decide about the operation, you can have something like this here. This is 6 and you can put 18 over here. 6 and 18 can be considered as parts of this whole. We're looking for the whole, so we have to put the parts together. Yeah? When we put the parts together, we have to add these parts. So we add 18 and 6. 8 plus 6 is 14. And then 1 plus 1 is 2. Therefore, there are 24 red plates. Did you get that? So to check whether your answer is correct or not, then you have to go back to your problem and try to answer the problem again. If you get the same result or the same answer, then your answer might be correct. Let's have our final problem, problem number 4. There are 304 girls in a school. There are 46 fewer boys than girls. Fewer than. That's a keyword for comparison model. Remember of that. And question letter A, how many boys are there in the school? Question letter B, how many children are there in the school? There are 304 girls in a school, right? Do we know the number of boys? No, but we know that there are 46 fewer boys. We have to look first for the number of boys. Afterwards, we can put the number of boys, the number of girls together to get the number of children in school. That's our plan. And in order to carry out our plan, we have to draw a model, and it's a comparison model. We have the number of girls and the number of boys. It's also important to determine which bar is longer. It should be the bar representing the number of girls. And the number of boys is shorter because it says here 46 fewer boys. Okay, there are 304 girls and the number of boys is question mark because we don't know yet the number of boys. This is question letter A. And the 46 here is what we call the difference, the extra. This is the difference because we have here 46 fewer. So there is fewer or more. You have to put it here, the difference. And letter B is asking for the number of children in school or the total number of children. So if you're using a comparison model, the total is here. This is our question letter B. And in order to get the total, you're just going to add the number for the longer bar and the number for the shorter bar only. The difference here is not included. Okay? So to answer letter A, this is how you're going to write your answer or solution. You have to put letter A to indicate that you are solving or answering question letter A. We have here 304, and this can also be considered as 46. Sorry, it's color green, so it's hard to see or to read 46, but this is 46. This is part. Another part is missing. So if a part is missing, you subtract. So we have to subtract 304 and 46. Okay, so 4 minus 6 cannot be, so we have to borrow from here, right? So this now becomes, oh, this is 0. We have nothing to borrow from here. So we still have to borrow from here. This now becomes 2, and this now becomes 10. Okay? So we have now something to borrow from 10. So you borrow from 10, this now becomes 9, and this now becomes 14. 14 minus 6 is 8. 9 minus 4 is 5. And you bring down here 2. So your answer for letter A is there are 258 boys. Okay, so how do you check if your answer is correct? We can use the opposite operation. So this is the checking portion. We have here 258 plus 46. Let's see if we can get 304. 8 plus 6 is 14. 5 plus 4 is 9 plus 1, 10. 1 plus 2, 3. It's 304. So this is correct. So the number of boys is 258. To answer letter B, there are blank children in the school. So we're just going to add the number of girls and the number of boys in school. There are how many girls? 304. There are how many boys? Our answer is 258. There are 258 boys in school. So we have 4 plus 8, 12, carry 1, 1 plus 5, 6, 3 plus 2, 5. So we have here 562. That is the total. That is the number of children in school. Okay? So that's how you are going to solve a word problem. Just follow the UPAC process. U, understand the problem. P, you plan what to do. You can draw a model, and you have to decide what model is appropriate for this particular problem. And 3, letter A, answer. You answer, you add, or you subtract in order to get the answer. Okay? And your decision should be based on the model you have drawn. And number 4, you check if your answer is correct. Okay, so I hope you learned something from this video, and see you in my next videos.